Okay, in this section we're going to talk about this concept of a cluster-wide commit, i.e. a replica set-wide cluster-wide commit for that, and what we call write concern in the drivers, which is based on get last error, which is a helper command we've used several times so far. So let's go over this. You'll probably recall in a previous section we talked about replica sets, right? Beyond doing just basic replication, the things we're getting from them are automatic failover when a node fails and automatic recovery when that node comes back. So when the node comes back and recovers, there can be a rollback of some operations which never made it out of that node to the other ones. They may not have made it out before it crashed because the replication is asynchronous. So those are archived, could be recovered, but the question on my mind is, how do we know when something has made it far enough and around that we're never going to lose it? And how many servers does it have to get to before the rollback becomes impossible, right? I mean, if it's on, it sounds like if it's on one server, it can be rolled back. Does it have to be on all of them to be guaranteed durable forever? Or could it just be on a subset of them? And the answer is that if it's on a majority of the servers in the set, that implies it's committed, and by committed, durable in a cluster-wide fashion, even with failovers and recoveries of nodes that have gone down. And that is the concept with cluster-wide commits and replica sets. And we look at this a little bit more. So there's a client out here that does a write. That write's going to replicate to these other servers. But it could make it to the disk here on the primary. Primary then crashes before it made it out onto the network. So I had this right here, made it to disk, machine crashed, never made it out to the others on the network, so really no way they could possibly have them yet, at least not in this particular architecture. I suppose I could have tried to blast packets at all of them simultaneously. Even if I did that, you have a little bit of the same thing where the client could have crashed after some fraction of those packets got blasted. So what to do? So there was a write here, didn't make it out to these, and this machine could be lost forever. And if you think about that case just for a second, if you just imagine the case where you just have one server and then I have a client, I do a write, and the write lands here and this thing crashes, and let's suppose it crashed pre-acknowledgement. I didn't get any acknowledgement back. Right, so the write may have happened or may not have happened. It may have been committed or not. So this would be sort of a classic single server case. And if it did make it to disk, if this server is going to be out of commission for 12 hours while I wait for the power supply to show up to be replaced, I can bring up another server, but that write of X, let's say of something X, if it's on there, I can't really get to it there, right? So I can either spin up another database to take over that doesn't have X, or I can wait and stay down. Seems like the obvious choices for me. So we got a little bit of that going on over here too. But note, of course, the write wasn't acknowledged, so there is no assumption that it made it, right? It may or may not have made it. And we're going to have something very similar over here where we can treat this whole cluster, if you think of that as a cluster, as like a single logical unit we can get acknowledgments from. That's what we're going to do. So the way we do this in Mongo is there's just a couple principles to replica sets. So the first is that write is truly committed upon application at a majority of the set. So if the write's been applied to 2/3 of this set, since there's 3 of them, it's truly committed. We have a cluster-wide commit. The other concept or principle with replica sets is we can get acknowledgement of this. So this number 1 might be fine, but it's like I want to know if it happened and tell me when it's done, right? So in Mongo, in a replica set in Mongo like this one, what will happen is the write, and here I'll give it like an exact name. We'll call it W1. So it's coming into P, it's written at P, it's on its way to the other ones, and then let's say it's made it to this one and it's still in transit here, right? So what's going to happen is there's going to be an acknowledgement back to this server that it's made it to here and been applied. So now when the client, if it does a get last error request, which is done automatically if we set write concern, we can get acknowledgement back that a certain number n of servers in the set have applied the operation. So we can get acknowledgement from a majority, for example, would be the most important case. And we'll get that acknowledgement as soon as the write has been applied to the majority, plus a little network time. So we would not be waiting for this server if we already have it applied on the other two nodes. So that's sort of our notion here. So the general way we would write this is, the drivers have their own syntax, but I'll just kind of do a bit of a shell syntax. It's sort of, we'll do the write, for example, and then we would call getLastError with W colon majority. And we could do a timeout also if we want, at which time we'll get an error back. So that timeout is in milliseconds. So this combination of things, if you will, is a write with a returned acknowledgement when a cluster-wide commit has occurred. So once that cluster-wide commit has occurred, W majority, the data is committed and durable on a cluster-wide basis. So by default, this is a good notion, this W majority. The W parameter lets us say how many servers we'd like acknowledgement back from. We could specify a number, right? We could do W1, W majority. We could do them all. I think there's an all string that works. You could do 3. It's best to use the string names like majority. That way, if the set's reconfigured and the number of nodes that form a majority changes, the clients don't need to change, which would be kind of silly. So while you can do 1 makes sense, I think, regardless, but other than 1, I think all and majority are good ways to go.